Hey all, Mooch here. Welcome to episode 3 of Minding Your mAhs. Just a quick reminder, I'd like to say that I won't be able to answer questions in the comments. There's already a couple hundred a day I'm doing in other places, but they do guide me for future topics. And they let me know what you're interested in, the kind of things you'd like to see me cover and all. So please, questions you do ask in the comments or any feedback you give me is invaluable. In addition to the likes and dislikes, it lets me know which topic you're interested in or not interested in. Dive right into the first one I'd like to address tonight is addressing batteries just by their color. The pink Sammys or the Smurfs or the green ones, things like that. It works great, it's fun to do, but it can cause a lot of problems for a new vapor who's asking about a battery or who you're telling about these batteries. And one example I'd like to show is this. These are 4 batteries from 2 different companies, LG and Samsung, ranging from 30 amps down to 5 amps. 30 amps, for the LG HB6 and about 5.2 amps for the Samsung 26F. So it can cause a lot of problems if we just say color of the battery, the pink Sammys or something like that. Because I go to IMR batteries or look at another battery website and there's a million pink batteries there. And I see a lot of posts from people who say, I've heard the pink batteries are great, but mine perform like crap. And I realize when you get a picture of the battery, they didn't buy the Samsung 30Q, they have the 26F, a 5 amp battery. So if you can, at least for someone who asks, tell them the designator for it, 30Q or HB6 or whatever it might be, as opposed to just the color. And it'll make it that much easier for them when they go shopping for batteries. I get a lot of messages from vapers who are worried about the very high current levels being displayed on the regulated mod when they're using it. And almost every regulated mod for the main part of the display does not show the battery current. That is the current from what's being displayed is the current from the output of the regulator going to the coils, not from the battery going into the regulator. And we'll go over the differences here, but a couple of notes on this. You may have smaller icons, battery icons there with voltages next to them. That's going to be your battery voltage, but check your manual for your device to be sure. Otherwise, for the main display, you are not looking at the battery current and voltage. You're looking at the coil current and voltage. So go this way. Your regulator is really divided into 2. There's the input side. We've got the battery current going in, which we must calculate. That's not shown to you. Then what's displayed is the output of the regulator to the coil or coils. This is what you see. And for a multi-battery mod, 2, 3, 4 battery mod, that current here is going to be a lot greater than the battery current. So, you see 25, 30 amps here, you may be fine using a 20 amp battery, because you'll see in some of the equations we'll do a bit a little later what the differences are and why it means something. But just understand that for almost every mod, unless you have a DNA regulator board, DNA 200, DNA 75, and you've made the change in eScribe to display the battery current, I think they call it input current, what's being shown to you is the coil current, and you can't use that to determine if you're running your batteries too hard or not. You have to end up calculating it, unfortunately. Now, you can use equations, which we'll see later on in this video, or you can also use rough wattages, like a 15 amp battery is 45 watts, a 20 amp battery is 60 watts, so 2 20 amp batteries, 60, 120 watts, and you can work out roughly what's going on there. But for different combinations, or if you just want to know what's going on, the equations are helpful, and we'll get into that later in this video. Next, calculating battery current for regulated mods and related topics, batteries in regulated mods. Now, got a couple things to go over here, and we'll try and make it quick, not make it a long one tonight, but there is a lot to cover because there's a lot of different types of regulated mods and different ways that they work differently from a unregulated or mechanical mod. The first most important thing, well, not the most important thing, one of the first things is PWM. That is not regulated. A PWM mod is not a regulated mod. It merely modifies the output. As the battery voltage drops, the voltage to the coil is going to drop also. You're just chopping it up into pieces and lowering the power that it's coming from the battery as that battery power lowers. Now, there may be a regulated PWM mod, but just a straight PWM mod that's got a MOSFET and a timer flicking the current on and off, little potentiometer, might be controlled or modified, but not regulated. So just get the terms set there. Regulated mods are not safe. They can be safer than using a no safety feature of mechanical mod, no inner sleeve on the mod, no insulator rings and things like that in certain places. But we can't assume using a regulated mod is inherently safe. There are still things that can happen. The mod itself can fail. The condition of the wraps of the battery and the insulator ring at the top are still critical. A concern in a regulated mod with multiple batteries, if two batteries are able to touch, one of them is going to short circuit, even if just the outsides of the cans touch, because they're in series. And I'll do this in another video. I'll show some nice diagrams and everything. But those cans are different voltages because of the fact they're wired in series. So if you touch two of them together, you might be touching 0 volts to 4.2 volts. Boom, one of the batteries is short-circuited. So we can't just assume a regulated mod is safe, but it can be a lot safer. But you still have to take a lot of the same precautions that you take for using mechanical or unregulated mod. The mod will do its best to protect itself, though, if the protection circuitry is working. We should always assume it's not going to. A lot of people will keep their batteries in the mod overnight. I say that, take it out. You never know. There have been occasional instances of mods 6 hours after use, just, melting down, catching fire. At least put it on a non-flammable surface if you're going to put the batteries inside. Never trust your safety to something that may or may not have been well tested, that may or may not have a defect of some kind. We just don't know. So don't make the assumptions it's perfectly safe just because it's regulated. It's still important because of that to match the batteries to the power settings. We don't want to just say, oh, if I accidentally put some 10 amp batteries in there or 5 amp batteries in there, everything's perfectly fine. No, it's not. That's only if the protection circuitry can help you out. If it's working properly, we don't know if it is or isn't. The wraps still have to be in perfect condition, all these other things. So it's still better, and we'll go over some choices to match the batteries to it and not just say, oh, throw whatever in there, the mod will turn off if it can't fire it. Yeah, a lot of times it will. But this is our safety we're talking about. It's not worth taking a chance when it's easy to just match the power to the battery. Probably the most important thing when working out how to size a battery for it is the coil isn't connected to the battery in a regulated mod. The coil, you've got, oh, that's not going to work. You've got a battery coming out to the regulator circuit, which goes to the coil. And this is just a battery, or multiple batteries. Now, this battery has no idea there's a coil here. This could be a light bulb, a fan, LEDs, it could be anything. It only sees what the regulator asks from the battery, how much current the regulator draws. And since this regulator is set to constant wattage, that's all the battery sees, a constant power draw from the regulator. The coil resistance doesn't matter. If it's a 0.1 ohm at 75 watts, this is asking for 75 watts in the battery. If it's 0.5 ohms at 75 watts, the regulator's still asking for 75 watts in the battery. The coil resistance does not matter when you're in VW, variable wattage mode, or power mode with a regulated mod. And we'll see some of that when we do the equations. A couple of just tips on using it. You can discharge down to any voltage you want to. The mod will turn off at the lowest I've seen is 2.8 volts. Our batteries are rated to 2.5 volts. If you stay above 3, and most of them turn off at 3.1, 3.2, or we'll say, low battery, weak battery, something like that, or they'll throttle back the power level so it doesn't drop below 3.1, 3.2. That's fine. You can get a little extra battery life versus 2.8 or 2.5. But our batteries are rated down to 2.5 volts for every single cycle. So it doesn't hurt it if it's going down to 2.8 or 3 or something like that. You can charge at any time. take 5 pulls, recharge them, take 5 pulls, recharge them. That's a very mechanical mod thing. I can't see why you'd need to do that regulated mod, but you can charge them at any time, put them back in the mod. I recommend not charging in the mod just because we don't know if that particular circuit is reliable and safe or not. It's faster, easier to monitor, and just overall safer to use a good external charger and charge the battery in that. It makes it easier in a million ways, and it saves your USB connector from wear and tear in case you need to use do an upgrade of the firmware inside the device. When we do these equations here, something that's very important, and we'll start that now, is we're going to approach this from what each battery needs to supply in terms of current. That is, we'll divide the total power by the number of batteries. That way, it doesn't matter if you have a series or parallel mod, because batteries each just give what they have to give. They don't care what's next to them in line or not. So if we calculate the wattage per battery and thereafter the current per battery, we're set no matter how they're hooked up, and we don't have to know if the mod is a series mod or a parallel mod or anything like that. So let's dive in. The two equations for calculating battery current in a regulated mod is, first, get the wattage per battery. Wattage per battery is just the total wattage divided by the number of batteries. And that's pretty easy. A 100-watt mod, 2 batteries, that's 50 watts. Get the current per battery. It's the wattage per battery, because we're doing it for each individual battery, divided by the lowest voltage that the mod reaches. Now, this is where regulated mods are different from unregulated or mechanical mods. With a mechanical mod, you use the highest voltage, 4.2 volts, to give you a little bit of a safety margin when calculating battery current. It's the opposite with an unregulated mod. You want the lowest current. Why? Because since we want 75 watts, let's say, all the time from the battery or batteries, as the battery's voltage drops, in order to keep that power level steady as the battery voltage is dropping, we have to up the current. The power is voltage times current. So as voltage goes down, the current has to go up to hold the wattage the same, because it's always going to try to pull 75 watts, and the regulator is always going to try to hold that steady. So the most current is drawn from the battery when the battery voltage is at its lowest. And there'll be a cutoff point. I just call it V low. Typically, most mods I'd mentioned earlier, 3.2 volts, 3.1. That's one you can use pretty safely in these equations if you don't know. Otherwise, check, see if your manual tells you what the lowest battery voltage it will accept. This is per cell. Remember, it's always per battery or per cell. And then divided by efficiency. What it pulls from the battery, let's say you set your regulator, your mod, to 75 watts. What it pulls from the battery is actually a little bit more than that, because you lose some power in the regulator itself. And you can tell that by the device heating up as you use it. It can be anywhere from like 5 to 20%. A good number to use is 10% or so. So I use an efficiency of 0.9. It just works in the equation to divide there. If you're using a DNA device, maybe you can use 0.95. It's more efficient. If using other devices, or you want a greater safety margin, you can assume a lower efficiency like 0.8. So we use 0.9. So let's grab a couple equations and we'll work out a couple scenarios and see what the current per battery is. First one will be, let's say 75 watts in a 2-battery mod. Sorry about the handwriting. It's never going to get better. What we've got then is the wattage per battery equals the total wattage divided by the number of batteries. So it's just 75 divided by 2 equals 37.5 watts per battery. Now, if we want to get the amps per battery, then we're just going to take the wattage per battery, which is 37.5, divided by, we're going to use the typical efficiency voltage cutoff level, 3.2 volts. And we'll use a typical efficiency, 0.9. And that equals 13 amps per battery. Now, again, it doesn't matter how many batteries you have or how they're hooked up. Since we're calculating it per battery, you're all done, you're all set, and you can select what you need for that battery. You use a 15 amp battery for a little better efficiency. You can use a 20 amp battery. This is easily lost. The next example, let's do a 3 battery mod at 150 watts. And let's call it a 3 volt cutoff. 3 volt low. And we want the wattage per battery first, because we always calculate by battery. And so we've got 150 watts. And we'll want wattage per battery equals 150 divided by 3 equals 50 watts per battery. Now this is 3 batteries, not the 3 volts. 150 watts total divided by 3 batteries. The amps per battery, we're going to take the wattage per battery divided by the voltage, low, divided by the efficiency. So we have 50 watts. Now the low voltage for this one is 3.0. I'm not going to use the typical one because I've looked up whatever mod this is. We'll make one up. And I found out it's 3.0 volts. So it's 3.0 volts. And I'm going to take the same efficiency, 0.9, run that equation, and you get 18.5 amps per battery. And again, you could use a 20 amp battery or 25 amp battery, especially if you're chain vaping. It'd just be a lot efficient. The voltage won't sag as far. And that's it for a series of parallel. That's all you have to do to calculate the current through there. It doesn't matter if you have 1 battery or 4 batteries. We've got it per battery, and you're all set. Now, recommended batteries, since we're in power mode, variable wattage mode, we don't pick necessarily by current, but you can. You just go by the current ratings of the battery. If you have this, to save a little time, you can also just use the wattage, and you can use these. The VTC6 or 30Q, 45 watts each, I recommend staying at or below. And this is each. If you have a 2 battery mod, 2 VTC6s will let you do 45 times 2, 90 watts. A 3 battery mod, 45 watts times 3. For any of the batteries, it works that way. For up to 60 watts, use the HG2 18650, or for larger cells, the iJoy, the 4-leg 2700, the 20 amp rated one. It doesn't perform as well as the 5-leg, but it's perfectly good at 60 watts in a regulated mod. So there is a place for that cell. It doesn't have to be universally derided as being a lower performer than the 5, which it is, but there's still a place you can use it. Up to 75 watts, the VTC5A, fantastic battery. I don't recommend it like I do as an all-around, as I do for mAhs and unregulated, just because down at these lower power levels, these other batteries work wonderfully, and they're a terrific match for it. VTC5A is good, though, if you're a heavy chain vapor, even at lower power levels per battery. So 75 watts per battery. 2 battery mod, 150 watts. Up to 90 watts per battery, the LG HB6, that's a very low capacity battery, 1500 mAh. It's going to run out very quickly. If you're up to these kind of power levels, single cell is really tough. So I'd say start with some of the bigger batteries. The 2650, the NCR 2650 A, or the LG HG6 or the Sanyo NCR. These are 3000 mAh, 30 amp batteries, terrific batteries. But make sure they fit. Make sure 20,650, not 26,650. Or the 5-leg 2700s. Decent performing. 30 amp batteries that can be used very successfully in regulated mods, especially if you've got a couple of them. And two of any of these, 180 watts in a regulated mod. How could I forget about the 26,650s and 21,700s? Really, there's only one for the 26,650s. It's going to be what I rated at is 30 amps. The iJoy, Aspire, Gulisi, and VAP cell. Their wraps is 4200 to 4300 mAh. Up to about 90 watts or so. They're all the same battery, by the way. They all rewrap the same cell. So you can get any one of those. Up to 90 watts to get to the 30 amp rating, but they're really best down at 50 to 60 watts. They just 26650s just don't perform that well when run really hard. A lot of voltage sag, you can get a lot of early, weak, low battery alerts. So yeah, you can use them up to here, but you're going to be switching batteries a lot and getting very frustrated. For the 21700s, it's a single cell. These are both the same under the wrap, but they're rated very differently by the wrappers. For up to 70 watts, the VapCell Purple, they rate it 24 amps themselves, so I'm using their rating. 70 watts, 3750 mAh. Up to 90 watts, the Galeazzi Black, the S35 it says on it, they call it 40. No, definitely not. At 3750 mAh. Now these also, yeah, they have higher numbers here, but again, down to 50 or 60 watts. It's just, single batteries just don't work very efficiently at all when they run very hard. You get a lot of the voltage sag I mentioned and a lot of the low weak battery alerts. It's just a lot better, especially with regulated mods where you have options to use 2, 3, 4 batteries. It's a lot better and a lot more efficient. 2 batteries versus 1 is more than twice the runtime because they're operating more efficiently. So it really pays off with a regulated mod to put in the second battery as opposed to running 1 battery regulated mod as hard as you possibly can and constantly getting these low battery alerts. That's it for tonight. Well, it's tonight for me. As usual, any feedback you have is wonderful. If you have any questions, I can't answer them in the comments, but they will help me determine what topics are coming up, what things I'll have in different parts of different videos as we go forward, and we can take care of all the questions there. Thank you for watching.